It's your lesson 2 notes, similar figures. I'm going to jump down to similar polygons. I'm going to jump back up to the warm-up. You can see these two triangles here. These would be similar polygons. And the reason they will be similar is that they are the same shape. Okay? And the reason they're not congruent is they're a different size. So I'm going to say they're the same shape, but a different size. Okay. We're going to talk more specifically in a minute about what it means to be the same shape, but they're a different size. They're both triangles. They both look like the same triangle. Triangle DEF is just a bit bigger. Let's look at the warm-up here. It says Caden casts a 4.5-foot shadow at the same time that a flagpole casts a 15-foot shadow. So I got Caden here. Okay. And he casts a 4.5-foot shadow. Okay. And then there's a flagpole, and that flagpole casts a 15-foot shadow. Now we got to make an assumption here, and the assumption is that the angle that the sun is shining on the person is the same as the angle that's shining on the flagpole. So we get something that's proportional. So we're going to set up a proportion to solve this. We got to add a little more information. It says if Caden is 6 feet tall, how tall is the flagpole? So I don't know how tall a flagpole is, so I'm going to call that x. And I know that Caden is 6 feet tall. When I set up my proportion, there's a few different ways to do this. I like to compare the same thing from one picture to the same thing in another picture in the same fraction. So this first fraction, I'm going to compare Caden's height, which is 6 foot, to the flagpole's height, which is x feet. Okay, and then my second one right here, I'm going to compare the shadows. Now, we use Caden on top of the 6, so we got to make sure to use Caden on top of the 4.5 foot. So these are both Caden on top. If we mix them up and we put Caden on top here and then put the flagpole on top here, we'll get it wrong. And then over here, the x is the flagpole, so the flagpole's shadow, the flagpole's shadow would go here. So both of these two, the way they're compared is they're both the shadows, and this is the original object. Okay, so the fraction has something in common, and then what's on top is the person, and what's on top is the actual flagpole. Or sorry, is that person's shadow. This is Caden. So both of these two on top have to do with Caden. All right, now that we have them set up, we just cross multiply. We did this yesterday. This is a review. We do 4.5 times x, that's the cross here, equals 6 times 15. Okay. And 6 times 15 would be 90. All right. To finish solving this, we got to get x alone. We're going to divide both sides by 4.5 to get x alone, and we get x. Okay, we get x equals 20. All right, so I'm going to jump around a little bit. I'm not going to talk about these similar figures until we tell you why they're similar. So let's jump down on the notes. We'll have to slide back and forth from the picture. It says polygons are similar if and only if. And the first reason, so these two are key things. There are two things that make polygons similar. The first one is all angles, okay, all angles must be congruent. Okay, they must be congruent. If you want to write the word congruent there, that is fine. So if I look back at this, we're going to say these two are similar figures. So if they are similar figures, that means A corresponds with D. Okay, so A corresponds with D. They're in the same position. Those have to be the same angle. And then down here, B corresponds with E. They have to be the same angle if they're similar figures. And finally, C has to be the same angle as angle F. These now have to be similar figures. So all angles must be congruent. There's a second reason. Oh, sorry, we're going to go back here, finish this out. A goes with angle D, just like we just wrote above. B goes with angle E and is congruent to angle E. And C is congruent to angle F. The second thing that must be true for these two to be similar is that all sides must be proportional. Okay, and by proportional, it means that we get fractions that are equal to the same thing. Like if I simplified the sides, I'd get like 1/2. Let's say I got a 2/4, and let's say I got a 4/8. Every one of these would simplify to 1/2. They would be proportional. So we'll work that out. So let's look above. It says AB goes with what side? So we're going to compare sides here. So first we got to know what sides to compare. So side AB, if I come up here, I'll highlight in blue. Side AB, it's got 2 letters, goes with what side on the other triangle? That would be side ED. So side AB goes with side ED. So if I come down here, I'm going to put side ED. I'm also going to do 2 things at once. If AB goes with ED, notice down here for the similarity ratio part, AB is on top. AB is 6, so then we're going to put ED, which is 8, on bottom. Okay, this is going to be my my ratio that I'm going to look at and make sure that all 3 of these are the same. Okay, so let's go back up. BC goes with what side? So if I look here, I got BC is right there, and that goes with EF. So and EF is 12. So BC goes with EF, and EF is 12. So if you look up here, if we compare these, if I took the small figure, I put 9 over the big figure, 12. Okay, and then last we have side AC goes with side DF. Side AC goes with side DF. So in every single one of these, we took the side that was from the small triangle and put it over the side from the big triangle. That's why it's going to work. We chose small over big every time. So if we look at the last ratio, we got 3. 3 came from the small triangle. That's going to be proportional with this side that comes from the big. So we're going to do 3 over 4, small over big, 3 over 4. Now when we look at this, we want to know, are these 3 the same? Or do they have the same similarity ratio? So similarity ratio is a common ratio of sides. Okay, it's a common ratio when you compare sides. So these don't look the same. So I'm going to say they're equal. They don't look equal. 6 over 8, 9 over 12, and 3 over 4 all look different. But if we reduce every one of these, so 3 fits into 6. Oops, sorry, 2 fits into 6 3 times, and 2 fits into 8 4 times. That would give me 3/4. Put that up a little bit. Then 9 over 12. If I reduce this, I can divide both the top and the bottom by 3. And 9 divided by 3 is 3. 12 divided by 3 would be 4. So that one is 3/4. And the last one is 3/4. So if you look at these common ratios, they're reduced. They should all be the same. Now I know for sure the shape up here, these angles are all equal. That's rule 1. Rule 2, all sides must be proportional. Because we got 3/4, 3/4, and 3/4, all sides in these shapes are definitely proportional. Okay, they're not equal, but they're proportional. So if we come down here, if we ask you for the similarity ratio, that's what we're putting here. It would be the reduced fraction. It would be this 3 over 4. Real quick, I'm going to show you one other way. If in your calculator you do 3 over 4, let's go back to the initial. 6 divided by 8, you're going to get 0.75. Okay. If you do 9 divided by 12, you'll get 0.75. You'll guess it. If you do 3 over 4, you're going to get 0.75 again. Now, the third way is if you cross multiply and then cross multiply again. If you cross multiply here, you'll get two numbers that are equal. Then if you cross multiply here, you'll get two numbers that are equal. But that's kind of the most work of the three. All right, so this 3/4 is your similarity ratio. So we'll go back up to the middle of the page. The symbol, this tilde, it's called. It's like the top of when two things are congruent. This tilde is saying that these two shapes here are similar. Now, order is very important. So we're going to say triangle ABC is similar to, now I got to, whatever I list first has to be equal to A. So whatever one I list first has to be equal to angle A. So I look here, angle A goes with D. So we're going to put D here. And then angle B has two tick marks here, goes with E. And then C goes with F. It has to be in that order. Notice something else. Now, remember AB was proportional to DE. So if you notice AB here is this side in blue. DE is first and second, and that's proportional with that side. So the order is very important when you write those because it tells us what parts are both proportional and what angles are equal. We're not going to worry about this part. We'll just skip over that because we already did it below. Okay, as we work through example 1, if I were you right now, I would pause the video and see if you can answer these questions. Notice this is asking for the measure of angle E, not the angle it equals, but how many degrees is it? Same thing with B. And now this is just creating proportions with sides. So you got to match the sides up with their proportional sides, and you should be able to fill these in. So I'm going to give you a second, or why don't you go ahead and pause the video, and then we'll fill them all in. All right, so if we look at angle E down here, I do not know how big that angle is, but because right here it has a statement that says ABCD is similar to EFGH, what I know is A is in the first spot and E is in the first spot, so I know those two angles have to be congruent if they're similar figures. So if angle A is 53, angle E must also be 53 degrees. Let's jump to B. So the measure of angle B is this top corner. Okay, I'm guessing it matches up with F, but I'm going to double check because it always tells us for sure here. B is in the second position and F is in the second position, so they should be the same. B is the same as F, and F is 127, so B must also be 127. Okay. For C, we got AB. I'm going to highlight it. AB. Compared to EF, or is proportional to EF. Okay, so I know those two go together. Notice they took the big shape and put it over the small. So this ratio is big over small instead of small over big. So now when we do AD comes from the bigger shape, okay, and that is proportional to EH, same side on the smaller shape. Okay. D, we got GH over CD. So now look at, we are small over big. If it's small over big on this side, it's got to be small over big here. Notice FG is the small side, and that is proportional with BC, which comes from the big quadrilateral. Okay, so these are proportions that are equal to each other. If we had numbers here and cross multiplied, they'd equal the same number. Okay, again, take a second. It says that ABCD is similar to EFGH, notice with a question mark. It's asking you, determine if the figures are similar. So if you look at these pictures, tell me if they're similar. Take a second, look at them. All right, what you should have written down is, right there's a problem. We said on the previous page that all angles in similar figures must be equal. Those two are corresponding parts, and they are not equal. So we're going to say no, the shape is not similar to that shape. And the proof is 30 degrees does not equal 35. So the corresponding parts are not equal to each other. Let's look at B. Notice for B, we can get through step 1 pretty quick. Step 1 is, are all the angles equal? So I look A and X, those match. B and Y match. And C and Z match. So all angles are equal. So I'm going to say all corresponding angles are congruent.